Hi students, welcome to my channel. In this channel, I am going to teach extended mathematics for IGCSE. My name is Rakesh. I am going to teach all the topics which are related to extended mathematics for IGCSE grade 10 students. Today, I am going to start numbers. This is the video of introduction to the numbers. Firstly, numbers. What do you mean by numbers? Now we will discuss about the brief introduction of numbers. Firstly, number types. So we will going to discuss the number types. As you know that, firstly, natural numbers. Numbers are denoted with the letter n. And what do you mean by natural numbers? Natural numbers are the numbers starting from 1 and goes up. And the second type of number is whole numbers. What do you mean by whole numbers? Whole numbers are nothing but natural numbers including 0. And then, so here the numbers are 0, 1, 2, 3, dash, dash, dash. And here 1, comma, 2, 3 and goes up. The third one is integers. So what do you mean by integers? Integers are the numbers, okay, along with whole numbers. So here the integers represented by z. So integers nothing but whole numbers including negatives. So what are they? Here, how these numbers are represented. So here all numbers are integers -2, -1, 0, 1, 2 and goes up. This side also goes up. Next. And the fourth one is rational numbers. Denoted by letter Q. Rational numbers are the numbers that can be written in the form of P by Q. So how we write these numbers? We write these numbers as in the form of P by Q. P by Q nothing but one consists of numerator along with other denominator. So numbers can be expressed in the form of P by Q or A by B. Numbers that can be expressed as A by B, where A comma B are integers. and b not equal to 0. This point is very important. B not equal to 0. Nothing but 1 by 2, 3 by 5, 1, 2, 0, minus 1. Along with rational numbers, natural numbers, whole numbers, integers. All includes in the rational numbers. So, next one is fifth one, irrational numbers. What do you mean by irrational numbers? What are the irrational numbers? Whether these irrational numbers includes natural numbers, whole numbers? No. So the next one is irrational number. Irrational numbers cannot be written in the form of fractions, non-terminating and non-terminating recurring decimals, non-repeating. Okay. Cannot, simply definition is cannot be written in the form of p by q. In the form of p by q. Then what are the examples? For example, root 2, root 3, 5, etc. These are the irrational numbers. For example, 1 comma 2 3 4 5 dash dash dash. This is a we don't know the end of these numbers, so it is considered as a irrational number. And the final one is real numbers. What do you mean by real numbers? Here, real numbers consist of all the numbers. So, real numbers simply written as rational plus irrational. So, I will give you a full clarity regarding this in the form of Venn diagrams. For example, consider this as a natural numbers. Here, along with rational numbers, natural numbers, if we consider this as a whole numbers, here 0 is added. That's it. And next, consider after the whole numbers what we have discussed, integers or GL numbers. Here, along with whole numbers, negative numbers are added. Okay, and after that, one more thing is one more number is here consider as it a rational number. So what do you mean by rational number? Along with negatives, decimals are added. So, and here it is separate, it is the irrational numbers. So by considering all these numbers, new numbers are arises called as real numbers. So real numbers is a combination of natural numbers, whole numbers, integers, rational numbers and irrational numbers. So this is the brief introduction regarding types of numbers, and our next concept is factors, multiples and prime numbers. And prime number, this is the new concept in this introduction. So firstly, what do you mean by factor? So numbers, factors are nothing but these are the numbers divide another numbers exactly. So numbers that divide another number exactly. Examples, for example, consider factors of, let us say 12. So what are the factors of 12? 1, 2, 3, 4, 6, 12. So here 1 divides 12 with a remainder 0, 2 divides 12 with a remainder 0, continuously up to 12. So 1, 2, 3, 4, 6, 12. Divides the number 12 and leaves the remainder 0. Then hence these numbers are called factors of that number. Next, multiples. Numbers found in a multiplication of a given number simply. So numbers multiplication of given number. So let us conclude this with an example. For example, multiples of 5. What are the multiples of 5? 5, 10, 15, 20, etc. and goes on. And next, prime numbers. What do you mean by prime numbers? Numbers with only 2 factor. What? 1 and itself. Numbers with only 2 factors, that is 1 and itself. For example, what are the prime numbers? 2, 3, 5, 7, 11, 13, etc. and goes on. Clear? And the next one is composite numbers. After that prime numbers, we are going to learn composite numbers. What do you mean by composite numbers? Composite numbers are the numbers with more than 2 factors. Numbers with more than 2 factors. So here examples 4, 6, 8, 9, 10, etc. and so on. And the next one is prime factorization. So what do you mean by prime factorization? Expressing a number as a product of its primes. So expressing a number as product of primes. Example, for example, 32, 36, for example, 36. 36 is written as in the form of 2 square into 3 square. So here 2 square 4, 3 square 9, 4 9s 36. Hence 2 and 3 are prime numbers. So 36 is expressed in the form of product of the prime numbers. And our next topic is LCM and HCF. These are all introduction related to the numbers, a brief concepts related to the numbers. In the next video, we will go with the complete in detail concepts regarding these numbers. So firstly, I will discuss HCF. What do you mean by HCF? HCF means the largest common factor of two numbers. The largest common factor of two numbers. So I will give you example also. And next, LCM. What do you mean by LCM? LCM means the smallest number that is a multiple of two numbers. So I will give you complete clarity regarding this LCM and HCF with an example. For example, I will consider 10 and other number take as 12. So what are the prime factors? 2 5s 10, and here 2 6 12, 2 3s. So 10 can be written in the form of 2 into 5. What about 12? 12 is written as 2 into 2 into 3. So here what I said, HCF means the largest common factor of two numbers. Here what is that largest common factor? Common factor, the largest is only 2. So HCF is 2. And what about LCM? It is the least smallest number that is a multiple of two numbers. So here 2 is as usual, and 5 into 2 into 3, which gives you 5 to 10, 10 to 20, 23 is 60. Okay, so 3 to 6, 6 5 is 30, 30 to 6, 60. So HCF is the 2 and LCM is 6. This is regarding LCM and HCF. And the next concept is standard form. What we are going to discuss now? Standard form. So what do you mean by standard form? Standard form means used for writing very large or very small numbers in the form of a into 10 power n formula. So in the form of, it is represented in the form of something, a number into 10 power n format. Okay, it is represented in the format this. So writing very large numbers or very small numbers. Regarding the two numbers, we are change that numbers in the form of a into 10 power n. So for example, I am considering 4. Okay, regarding these numbers, I am considering, for example, if I want to write this number, how many digits are there? Total 1, 2, 3, 4, 5, 6, 7 digits. So here it is represented as whether it is a 45. So taking the digits, especially in this format, taking the digits, neglecting the zeros. See here, I am considering this 45, and regarding after that I count 1, 2, 3, 4, 5 zeros. So 45 into 10 power 5. Okay, or else we can write like this also, 4.5 into 10 power 6. And for example, this is the example 1, and the second example is, so now we are taking a decimal number 0.0000032. Here it is written as in the form of whether, see, count how many zeros after the point, 1, 2, 3, 4, 4 zeros and 2 digits, 5, 6. Totally there are 6 digits. So here if we want to write this number, so it can be written as 3.2 into 10 power minus 5. So y minus 5. Here I kept point here. So this point is moved towards right. After how many digits? 1, 2, 3, 4, 5 digits. So here I place 3.2 into 10 power minus 5. Why? Because here y minus is we are rating decimal. So here the number is represented. So there is a positive and here we get negative value. And the next topic related this numbers is surds. So what do you mean by surds? What do you mean by surds? Surds are nothing but irrational roots. What do you mean by surds? Surds are irrational roots. So what do you mean by irrational roots? For example, write the definition. A surd is a square root that cannot be simplified into a whole number. So surd is a type of surd is a type of square root that cannot be simplified to a whole number. If it is converted into a whole number, then it is not a rational number, irrational number. That's why these surds are irrational roots. They cannot be represented in the form of whole numbers. They cannot be even rational. For example, if I write, let us give you two examples. Example 1. Here in the example 1, I consider root 16. It is a root value, so it is maybe it is a irrational number. Let us check. Here root 16 can be written as root 4 square, and 4 root cancel, square root cancel, we get 4. This 4 is a whole number, so it is not a surd. Surds are nothing but they are irrational roots. So in the example 2, if I consider root 18, root 18 can be written as root 9 into something 2, root under root 9 into 2. So here this root 9 into root 2. So root 9 gives you root 3 square into root 2, square root cancel. Here we get finally 3 root 2. And this is in the form of irrational root. So it cannot be converted into a whole number, or it cannot be simplified into a whole number. Therefore this 3 root 2 is called as a surd. As I said, surds are irrational roots. I hope you get a clarity regarding surds. Now I will give you one more topic: recurring and terminating decimals. So what do you mean by recurring and terminating decimal? Firstly, I will consider terminating decimal. Terminating decimal means here the decimal, how many in the decimal we can count how many digits are there. Okay, so we can count how many digits exist there. So it can simply a decimal that has an end simply. For example, 0.75, 0.5, 0.2, 0.533324. So these are the numbers that has ends after that point. So here point after 2 digits, point after 1, point after 1, here point after 5 digits, even 5 digits it has a end. So it is considered as a terminating decimal. And the next one is recurring. So what do you mean by recurring decimal? A decimal that represents indefinitely, nothing but the number which is repeated, the digit which repeats frequently. For example, here a decimal that repeats, right? A decimal that repeats indefinitely. So how we write this? For example, if I consider, so let us consider 0.3 bar. So it is known as 0.3333 up to infinite. We can't say how many threes towards the right side of the point. We can't count because they are infinite. So simply here 0. Even though 0.3 it is written as in the form of 1 by 3. So when we divide 1 with 3, we get 0.333. It has not an end point. Okay. So these are nothing but terminating decimals and recurring decimals. Okay. Let us consider. So how we can do this? For example, if I consider 0.6 bar, how can I write this in the form of P by Q? Is it possible to write that number in the form of P by Q? Yes. Regarding this, firstly, step 1. Considering step 1, here step 1 means we must how here after the point how only 6 gets repeated. So count the digits that repeats after that point. Here only one digit that repeats after that point. So how many number of digits here we multiply in that power of 10. So here one digit nothing but we multiply with 10 power 1. Okay, 10 power 1 which gives you 10. So in the first step we have to multiply with 10. So multiply by 10. 10. So here we get, for example, in this format, if we multiply 0.666 and it goes on. So here when we multiply with this 10, we get 6.6 bar. So here read this as a, for example, when I multiply with 10, I get, for if I consider this as a x, this number as a x, I get 10x is equal to, no, let me give you clarity. For example, if I consider that number as a x is equal to 0.6 bar. When I multiply with 10, I get 6.6 bar. Here is treated as equation 1 and it is treated as equation 2. Subtracting equation 2 minus equation 1 which gives you 10x is equal to 6.6 bar, x is equal to 0.6 bar. Here 6 gets cancelled. 10x minus x which gives you 9x is equal to 6. X is equal to 6 by 9 which gives 3 2s, 3 3s is equal to 2 by 3. Therefore 2 by 3 is equal to 0.6 bar. This is a recurring decimal. So and the next concept is related to bounding the numbers. So here bounding the numbers means getting nearest value. So bounding the decimals or numbers, whatever it may be. For example, when I consider 3.25, so it can simply written as 3.3. So nearest value. So here it is 2 represented by 3 only in one digit. Okay. For example, so if I consider 10.9, it's 10.9 simply written as 11. So I bound to the nearest number. That is nothing but bounding the numbers. And the final introduction regarding these numbers is percentage, ratio, and proportion. So we will discuss in detail regarding this percentage, ratio, and proportion in the upcoming classes. But here it is an introduction. So firstly, I will go with okay. Firstly, if I want to convert this percentage into fraction, percentage to fraction. What I have to do? So percentage to fraction, if I want to convert that percentage to fraction, I want to divide by 100. So divide by 100. Example, 25 percentage, nothing but 25 by gives me 1 by 4. And the next one, fraction to percentage. Fraction to percentage. Here, if I want to convert a fraction to percentage, I simply multiply by 100. So in the first case, it is the division, and in the second case, I want to multiply by 100. For example, 3 by 4 should be converted as a percentage. Is 3 by means 3 by 4 into 100, which gives you 3 by 4 into 100, which gives you around 4 2 so 4 5 so 25 3 so 75 percentage. And nothing, our next topic is ratio. So what do you mean by ratios? Ratios are nothing but simply expressing relation. Okay, expressing relationships. Okay, express relationships means for every 3 of 1 there are, for example, if I consider 3:4, so what is the ratio here? So ratio means express in relationship. Express relationships. Ratios means expressing relationships. For example, if I consider 3:4, so here what I written here, 3:4, it means for every 3 of one there are 4 of another. So here for every 3 of one, for every 3 parts of one, okay, there are 4 of another. Four of another. This is nothing but ratio. Then what about proportion? So this is the main difference between ratios and proportion. Proportion means equating the ratios. What do you mean by a proportion? Proportion means equating the ratios. So I will let you clarify the doubt. Ratios nothing but expressing the relationships, and proportions are nothing but equating the ratios. For example, 2 by 5. How can we write this 2 by 5? Here 2 multiple exist in the denominator, 5 multiple exist. And for example, if I want to write here 2 2s 4, 2 3s 6, then we have to write in denominator 5 3s, 5 3s 15. So which gives you same ratio, but here we are going to equating that ratios. This is known as proportion. Hope this introduction clarifies you regarding all the topics related to number, and this is the brief introduction related to number. So in the next classes, in the upcoming classes, we will discuss one by one topics regarding to the numbers. I hope all you people get clarity regarding these numbers. I am going to end the session. In the next session, I will discuss each topics. In the next class, we are going to discuss arithmetic and all topics related to arithmetic. Thank you. Thank you all. Hope you like the session.